Hello again. For this last chapter, we will see actually finally how you have to manage your virtual machine. So you have seen so far that we have created several steps in order to install the systems, discover file systems, block devices, storage as well, create pools, put our servers to the pools. Now the last part is how we have to create, first of all, virtual machines, because this is the goal of this course, okay? And then once that you have created virtual machines, maybe you have to perform different other operations like accessing them, like cloning them, because from one virtual machine you can create several copies, okay? So it's another advantage of the virtualization. And then we will see actually all these steps, okay? Installations by using disks, or installations by using more automation procedure functions like a kickstart. So actually the kickstart is not something I would be saying related to the virtualization. Once that you have let's say empty cells like virtual machines that are not installed, then from kickstart servers, PXE servers, you can launch this kind of automation, and you can install as many servers as you want, okay? We have just to review some very simple notions, okay? So again, the domain is a configurable set of resources that includes memory, virtual CPU, network devices, disk devices, in a way that is describing how the virtual machine will run. A virtual machine, a guest, or a domain U that we will see in the next slide. They are just describing the same feature, okay? Isolated environment, which is running as a guest operating system, okay? So a guest, it's a guest operating system which is running within domain on the top of an Oracle VM server. The DOM 0, if you recall, it's a management domain with privileged access to the hardware and to the device drivers. And then we are working with a Xen hypervisor because we are working with the X86, okay? So the Xen hypervisor, again, it's a small, lightweight virtual machine monitor, okay, which is controlling the most of the resources that you have in the host machine. The DOM U, okay, DOM U, guest, etc., etc. It's the same, let's say, virtual machine as we have seen before. And then your virtual machines, they can be classified into three categories. PV, if you recall, in this case, the PV machines, they are para-virtualized, they are aware about the virtualization, so the kernel is already modified. The hardware virtualized machines are installations that they have been done as you are doing this on the normal physical hosts without taking care that you have a virtualization. And HVM with PV drivers, it's an optimized installation of a hardware virtualized kernel for which the editor of the virtualization solution, in our case it's Oracle, has provided additional drivers in order to speed up, let's say, performances on the IOS. So please remember that for this kind of PV drivers, you have to download them from the edelivery.oracle.com site and not from the operating system editor site, okay? So how you can create now virtual machines? Okay, you can create them by using any kind of installation media or method that you have done it before. You can use ISO files, okay, from your editors. You can install them through the networks with or without a PXE server, okay. By using cloning with templates. Remember that Oracle is delivering templates, so templates pre-configured, not really ready to be used, but with some additional steps, this pre-configured virtual machine with your additional interview replies, it will be ready to work, okay? Virtual appliances, that means that you have, let's say, into one file, okay, or configuration, several virtual machines that you can use. And of course, the last but not least, which is really much more important, okay, it is the P2V, because maybe this is the most I would be saying important thing when you are starting your virtualization. The idea is that you have several physical hosts that are running somewhere, okay? and you want to make what we are calling consolidation. So you have several tools that they are making this kind of physical to virtual conversion, okay? The media that we have to install your servers, it's having also this kind of facility, and you have to launch it through a physical installation. Otherwise, in Oracle, we had also one tool which is not really mentioned so well here. It is the virtual assembly builder, okay? That it has been used to make this kind of physical to virtual consolidations. For more information, please open NSR to our friends of the support, that they will be delighted to answer to your request about the virtual assembly builder. Otherwise, you can import virtual machines or importing virtual disks from other places where the virtualization has been run. So in these cases, you might have, let's say, the virtual machine, okay? The configuration of the virtual machine, which is stored as a vm.cfg file into one repository. You can have several virtual or physical disks, okay? So Oracle says that, and other editors as well, that it's better to run your VMs, if possible, by using, let's say, physical mappings than virtual mappings, okay? So you avoid one extra level of virtualization. It's speeding up the IOs, okay? Otherwise, Oracle VM servers that they are into a pool, they will read the configuration file. From the configuration file, they will find the mappings needed to run the virtual disk. The VM CFG also is putting, let's say, an order on the a boot order of the disks. And of course, you need, before to start these things, to create virtual network interfaces, okay? It's like slots that they will be used to communicate with your virtual, from your virtual machine to external world, okay? So these things you have to create by yourself, and then you have your environment which is ready to run your business. For any virtual machine, okay, you have to, you need actually to say where, let's say, the whole artifacts they will be, from where the artifacts they will be run. Will you use a virtual disk or a physical disk? It's again up to you to choose the right configuration, okay? And then the virtual disks, they will be always stored into a repository. So there are disk image files. It's not really changed between the format of the Xen virtualization, it's .emg files. Physical disks on the other side are really LANs that they will be presented and mapped to the physical disks that your Oracle VM servers and manager, of course, the manager has discovered and presented to the servers, okay? They know where they are residing, okay? And of course, if you have unused internal disks, okay, they can be also seen as physical disks for the Oracle VM, okay? The thing that you need to set up from the beginning is through a tool which is called Virtual NIC tool. You can reserve MAC addresses that they will be assigned to your NICs with a certain, let's say, workflow, dynamically or statically, okay? The only thing that you have to create it is a pool of VNICs. So this is done again from a tool, graphical tool or a command line tool. So it's up to you to choose the right method just to be more familiar with the product. And then, if you recall, every time that you are creating networks inside the virtualization framework, bridges, they will be created, and the VNICs, okay, they will be automatically related to the network bridges in order to let the network traffic flow between the different servers from and to your virtualization framework. So this is the virtual VNIC tool, which is on the network tab of your manager, okay? And we can trigger it also with the command line. Now, you have to reserve, let's say, MAC addresses that they will be unique per manager configuration. So once that you have one manager, then the manager will generate this kind of VNICs in a unique way. The phrase that says the first 3 octets are already preset simply means that whenever you are working with networking equipments, okay, we have to rephrase it in a better way. The first 3 octets, they are associated to the editor of this kind of hardware configuration or virtual configuration. So the three first octets, okay, that are already preset. They are associated with the virtualization framework of Oracle. Okay, so you should not change them unless if you have a very good reason. In this case, please contact the support. Again, our friends, they will be delighted to have this kind of questions, and they will help you. But you are free to choose actually your own range of IP addresses by giving the next three octets, okay, the last three octets, okay, and this they will be stored once that you're creating ranges into the Oracle VM Manager database. So afterwards, you have to create a virtual machine. Okay, so creating the virtual machine means that you have to find the artifacts. You have to say exactly what kind of virtualization you have to see. We will see that there is a guided procedure. Okay, so either you can create the virtual machine by just clicking in the tab, okay, and then you have to follow a guided path. Either you have to use the CLI, okay. So as you can see here, whenever you try to use the wizard is asking you very stupid questions. Should I say this or not? Stupid questions. Okay. Or easy questions or dummy questions. Do you want to create a VM, okay, or do you want to clone a VM from an existing VM template? So please remember that the VM templates, they can be used to create automatically this kind of procedure, and this is a very generic fact for any kind of virtualization that you have in Oracle products, okay, or clone from an existing appliance. In our case, we are starting from scratch. We're getting the first entry, okay, and then as you can see here, you have a very easy way to go, okay. So you have to create a virtual machine by first of all setting up networks. You need to have a disk space for your disks. You have to tell the boot order, and then you have to create tags. Tags, I would be saying that it's not optional, it can be mandatory in the case that you have several VMs. So that tags are like bookmarks. If you have a lot of VMs in your virtualization environment, then without tags, you will nearly be lost. So you have to create these tags from the beginning, and it will be used to retrieve the right VMs by just performing some simple searches. So create a VM that it will run into a pool, okay, from a repository which is called NFS repository. Then you have to choose, let's say, an explicit name for your VM. As you can see, there are two additional checkboxes. So if you are working with a cluster pool, you have to choose immediately the enable high availability, otherwise you will run into issues. You have to choose the operating system, you have to choose the mouse type, the KMAP, the domain type according to the virtualization that you're gonna choose, and the starting policy, and some other facts, okay? So this VM, it can run to any Oracle VM server in the pool, okay? High availability and or huge pages, okay? It's not something, okay? The most important thing is that you have to know exactly how you have to run or install your VM, HVM, PVM, okay? Start policy to the best server of your pool, and then you have to say what is the memory that it will be used, and some other configurations about giving the priority, how many processors, and the processor cap, which is the cycles that they will be used for from the system to run your servers. Then you have to create, as you can see here, virtual NICs cards, okay? So remember that you have two choices, okay? Either dynamic, why not, or more controlled, it will be specify the MAC address. So another choice that you have here, it's the part 2, you have to choose the right network, okay? So if you have created several networks, then you have to choose the right network for your VM in order to be sure that it is working as expected, okay? And then the next thing is, okay, a VM needs disk, okay, disks in order to run, okay? So either you have already disks that are existing to your system, either you have to create them, okay, by just clicking create, okay? And of course, this can be a virtual disk, a physical disk, or you have to be careful a little bit about the way that you are working with the virtualization. It can be also CDs or DVD-ROMs. Now, if you read this slide very carefully, you will see that we are working with the PVM, okay? So for the PVM, and this is related to the Xen environment, CD-ROMs, CDs, yeah, they are not really supported, okay? So in this case, you don't have, let's say, the boot option as a CD. So you have a PXE server and a network boot path that it has to be given, okay? So in our case, and we will run the labs, so you will see all these details. We have, let's say, an access to this, let's say, server which is exposing the OL6U5 distribution, not in a .iso format, but it has to be into an exploded format, okay? So if you put ISOs in this network path, you will never be able to boot them with PVM. You have really to explode them, okay? You will see this technique in the labs, and then you will be able to work with the PVM. If you had an HVM, okay, then the choice of the CD-ROM, it will be valid, okay? So what are the steps they will perform into the virtualization, okay? All these steps, creating the Linux, setting or the way that the VM has to boot PVM, HVM, etc., memory, pools, disks, they will create this famous vm.cfg file, okay, that it will be stored where? To a repository. Remember that a virtual machine has to run from a repository, so into this repository, in the section of virtual machines, you will have this kind of vm.cfg, and of course, instead of running all these things graphically, you can use the Oracle VM CLI. So all this documentation also, documentation about how you have to create Oracle VMs by using the CLI, it is given in a more explicit way in our documentation. So you have to download from the docs.oracle.com the document which is exposing the VM CLI. So this file is created automatically by you. It will store to the repository. So if you start to read it, for people that they have run already this kind of Xen virtualization, it's a very familiar file. If you take the last line, okay, you see the OVM underscore domain, it is Xen underscore PVM. So simply as that means that you're running a PVM modified kernel, okay. The bootloader, which is just the third line from the bottom, it will use the USR-bin Xen PV boot. So all these things, they are set up automatically. Okay, then a UID, it will be created automatically by the system. On the top, you have the virtual interface that you have associated to your systems. And then if you will see, there are several disks, okay, that they are exposed as, let's say, virtual disks. Why? Because the term is file, okay, file, and every disk, it is stored, as you can see here, in the 2./OVS repositories with the ID of the repository, virtual disks, and then you have, let's say, the Xen format, which is .emg, okay, and you see maybe that there's an associated CD-ROM, okay. The network path is there as boot args, okay. Max memory size, it's whatever you have already entered to the system, okay. So /OVS repositories, it's path for virtual disks and ISO files. Otherwise, you will see, let's say, dev mapper, that it goes straight to the SAN storage area. And then you will have, let's say, additional flags, okay, read, write, or shareable disks, okay. Remember that whenever you are creating disks, these disks, they can be used also as a shareable media, especially if you are working with real application clusters, okay. So now how you will find this vm.cfg file, remember that this is stored to your repository, okay. So you have to go to the correct repository, so you have to find the repository ID, virtual machines, / the UID of this virtual machine, and you will find it there, okay. Now, usually, whenever you want to work with this kind of configurations, okay, either you will get the name of the repository from the configuration tab or from the command line, and then you have to get logged into the OVS servers, and from there you have to find, as they are giving us here, the /OVS repositories. So this is the ID of the repository that you have to work on, and then you have to go into this repository, you have to go to the virtual machines, okay? You might have different, let's say, several virtual machines, so for each virtual machine you have a specific ID that is generated, so you have to know the ID of your machine, and then you are ending up by finding the vm.cfg. Otherwise, why not? It's fun. You have to write your own scripts that they can locate this vm.cfg inside your virtualization. Once that you have this kind of construction, then you can start the virtual machine, okay, and then associated operations with this virtual machine, they will start it. If you are installing them from scratch, then you will have, let's say, menus that they will guide you for the installation of the operating system. If an operating system is installed already and configured, then the only thing that you have to provide then, it's an operating system user, and then you will be able to run any kind of operation, okay? So, in this case, we have, let's say, a screen which is popping up from an installation process. So in this virtual machine, there is no installed any kind of operating system, so it's just like booting a physical server, okay, where you have inserted installation media, okay, and then the only thing that you have to do, okay, because you don't have any operating system, it is just to follow the installation path. Remember that this is a PVM, so you have to give exactly the network boot path with an exploded ISO format, okay? It is a PVM, so it has to boot from a network path. On the other side, if you're familiar for your installations to use kickstart files, okay, then it's not something different than normal installations. You have to provide a kickstart file and a PXE server with, let's say, traditional configured DHCP, TFTP, and all these things. And then from there you are forcing, let's say, the boot and the installation in a more automatic way if you need to install a number of servers dynamically, okay? Quiz, and then we will pass to the second, okay? With a virtual NIC tool, you can create network bridges for virtual machines, reserve VLANs IDs for creating VLAN interfaces, reserve MAC addresses for your virtual machine VNICs, or assign VNICs to existing networks. I think that the most obvious answer to this, it is that the VNIC tool, it is used to reserve MAC addresses for virtual machine VNICs, so the answer is C. This is the end of the chapter 6, part 1. Okay, thank you very much and see you. Chapter 6, part 2. Chapter 6, part 2. Chapter 6, part 2. Okay. Templates. So now we will see the notion of template, virtual appliances, and cloning. Okay. So these are operations that, or notions that you have to master in order to work with the virtualization. It's not very difficult. Again, we will have a first part which is just giving some notions, and then we will pass to the real introduction of this or application of these notions to your IT systems. Okay, so remember that a template, it is a pre-configured virtual machine, okay, that it can contain several or one virtual disks, okay, and some configuration information. So the template by itself, it's not ready-made, it's not ready to run as a virtual machine. We have always to provide some additional information in order to configure it, okay. On the other side, virtual appliances, they can be seen as a more complicated configuration than templates because they can contain several virtual machines, okay? They are pre-built, okay, to deliver whatever, okay? But they are not still ready to run as virtual machines. You need to generate from these virtual appliances templates, and then from the templates you have to create virtual machines. We will run these labs a little bit later. So how you have to make this available? So simply by using the import function, okay? We will see how you have to run it in the labs. And once that you have, let's say, something into your repositories and you want to move it to other repositories, there's an export VM function, okay, or export template or export disks and whatever, to export them as artifacts and to be imported to some other systems, or cloning, that it will be used to clone any kind of configuration to another, let's say, to another instance, okay? So now we have, let's say, a new format which is called OVF, okay? So the virtual appliance is containing, let's say, a set of configuration files in this format, OVF, and maybe several disk images. So whenever you have to manipulate this kind of virtual appliances, you have to import them, okay, as a single .ova file, okay? And then you will see that several things that will happen. So you will have, let's say, elements that they will be created. We are calling this unpacked. So actually, tar files, they will be untarred, okay? And new directories, they will be created with the artifacts, okay? So once that you have created this kind of, and finished this kind of import, okay, then you have to create template for the virtual machines that they are included into this virtual appliance, okay? And then cloning it used to create this kind of virtual machines, okay? So create now a new virtual machine with cloning. So the cloning, it will be used to create a new virtual machine or a template-based virtual machine, okay, from a virtual machine or from a template. So the cloning, it will be used to, as the term says, to create a virtual machine with similar characteristics. And again, this is very important. As the copy that I have been exposing before, we have two situations, cold or hot cloning. The best situation, the most recommended, is the cold cloning, where the cloning is done when the virtual machine is not running, okay? So you will get a consistent file system, and if you are not able to stop the virtual machine, then you have to perform a hot cloning by having a risk that maybe this kind of resulting virtual machine is not consistent. So in this case, you have to run some additional checks, Linux checks or Windows checks, whatever, in the file systems. And if you are lucky enough, then you get you will get a running a virtual machine. Otherwise, you have to perform again this kind of hot cloning, and up to the moment that you are able to have a consistent system, okay? So another thing that we will see a little bit later, it is that you can clone a virtual machine with the same configurations. We are calling this simple cloning, or you can make some modifications that we are calling this advanced cloning. So as you can see here, you can launch these operations either with the user interface or the command line, okay? You can start to clone from a virtual machine, okay? And also you have a clone count. It will be used actually to create on the fly several copies of your virtual machine in one single operation, okay? If you don't have to perform some additional optimizations or changes on your clones, you don't have to choose the advanced cloning, okay? And of course, you have to provide repositories that they will hold your final artifacts, okay? The same operations, they can be launched from the CLI. So here the developer has just put the API, okay, clone VM, the name template, destination type, the name of your new name, okay, and where you have to clone to a server pool, which is called my server pool 1, okay. Cloning considerations. So when you are cloning from NFS repositories, okay, you can create the clone to any server that is present to this repository. When you are cloning with the OCFS2 type repositories, the clone, it has to be associated with the current server pool, okay, and the target, okay, it can be in a different repository, okay. Now, when you are cloning within the same OCFS2 type repository, so remember that we have an optimization that is called thin cloning, okay, so we are just using the written part of the artifact, and this is done by default. So we have here just a simple workflow that says simply that whenever you have to clone, either you are making a simple clone without any additional features, okay, and the clone, it will result either as a virtual machine or as a template, and from the template then you can clone the template or you can clone a new virtual machine, etc., etc. Or the advanced clone, that means that if you don't have a feature that is called clone customizer, which is instructs how you have to perform particular operations, okay, then you have to create one. If you have created one, then you will use this clone customizer, which again, it will create you a template or a virtual machine, but with new feature, okay. So the clone customizer, it can be created straight from the cloning wizard or from the clone customizer wizard, okay. So you will use the clone customizer, okay, by just giving name descriptions, okay, and for its disks you can create or you can remap them into different locations, and for each VNIC, of course, you can create a new VNIC, you can create new target networks, or you can change the number of the VNICs, because maybe the initial, let's say, virtual machine was having 4 network interfaces, and for this customization you need only 1 or only 2 according to your requirements to the services, okay. Then when you are creating, let's say, storage mapping, you have to specify usually the target type, it's a repository or a physical disk, the clone type, sparse copy, non-sparse copy, thin copy, okay. Again, you have to be very careful about this kind of thin copies, and your selection for the clone type depends on the current locations of your disks, okay, and the clone target type, okay. And we have some examples. So OCFS2 repositories to the same repositories, okay, to the same repository, sorry. So you are working inside of the same OCFS2 repository, so you have to use the thin copy, okay. Repository to physical disk, then you have the selection of sparse or non-sparse copy. Which one is the best one? It depends on your own requirements again. Physical disk to physical disk in a managed storage array. So inside the managed storage array, because you have, let's say, specific plugins, and again, you have to use the thin copy. So our developer in this kind of scenario, he starts to tell us that from one template, okay, which is residing to NFS repository, you can create actually through 2 clone customizers 1 and 2, okay, 2 configurations that they will be used to clone disks, maybe create virtual machines to a managed storage array or to an OCFS repository 3. So both templates, they will be created through the clone customizer to an OCFS2 repository, and then according to the template, either you will go with template B to create actually disks to repository 3 OCFS2, either with the C you will go to create actually your configurations to a managed storage array, okay. So this is just an optimization or a change of the configuration of the storage, okay. Now another thing, cloning operations summary. If the source for the cloning operation is a virtual machine and the hot cloning is not supported, stop the virtual machine. So this is very logical. How you will know that the hot cloning is not supported, I will be saying that we don't know really, okay, unless if somebody has tried already, okay, or if you have some specificities about the operating system. So maybe the support will know better than me, okay. So you stop the virtual machine because you want to make a consistent copy, okay. So remember that you have 2 kinds of clonings, okay, called them hot. Cold cloning is always giving you consistency, okay. When cloning with an OCFS repository or within managed storage, it's better to use the thin cloning because you will copy only the part which is written, okay? Cloning between repositories or to physical disks, the cloning process uses a copy operation, so sparse or non-sparse, okay? If you have, let's say, a clone customizer which is using an existing physical disk as a target, then it might be wise to make an update of the target physical disk, okay? Just to have, let's say, the latest snapshot of the content, and then you can edit your new clone, okay, always to supply missing information. So a clone is always a clone, and you have always to check that this new generated artifact it is consistent with what you have so far. Okay, so we have seen actually how you have to create virtual machines, okay? So the next step it is to see the life cycle of these objects, what are actions you can implement and the high availability. So here we have, let's say, different states of virtual machines. So whenever you are creating a virtual machine, so the state of the virtual machine, it is stopped. From there on, you can go to start it. Starting the virtual machine goes to running. From running, you can either suspend it because you want to freeze the operating system, or you want to stop or to kill it. So normally you have to stop it. It's a graceful stop. And if the machine has to be stopped immediately without any delays, then you have to kill it. Okay. And then you have to restart it, or you have to delete it. Delete it means that you're deleting the configurations, okay? And maybe sometimes the physical disks or the virtual disks. And once that the server is stopped, then you can restart it as many times as you want. So now, once that you have started or created the virtual machines, okay, the ultimate goal is to use them. So of course, you should be able to get connected to these virtual machines according to the operating system users that you have created, okay? You can, let's say, migrate or move the virtual machine, okay? And you can change characteristics of your virtual machine because you have given a certain amount of memory, or you want to change or to add some disks from the vm.cfg, okay? You have created a virtual machine with Windows, and then you want to install some drivers in order that this kind of configuration works a little bit better. So, sorry, okay, I have done this one. So, migrating a stopped virtual machine, okay? Actually, with call migration, okay, you have, let's say, several destinations to choose when you're doing this kind of things. There is a folder which is on the left side of your manager, which is called unassigned virtual machines, okay, unassigned in the current server pool to a specified VM server, okay, or to a specified server pool. So this is where the place of this virtual machine will be targeted. And then if you have, let's say, a running virtual machine, okay, then you can perform what we are calling live migration without having to trigger, let's say, a condition that it is pushing with the dynamic scheduling from one compute core to another compute core, okay? So we see here that the Oracle VM servers must be in the same server processor compatibility group, okay? So remember that in these cases, we have pools that they have the same configuration, okay? And this is the most important phrase, that the target server, they have to have, let's say, adequate, first of all, memory. This is the most important thing, CPU and storage resources, but the storage resources, let's say, we will see them through the repository. The most important thing is the memory, okay? Oracle VM servers, of course, they have to run the same version of Oracle VM, which is, let's say, a real mandatory thing, but this phrase maybe it has to be rephrased. Maybe we can say that if you have virtual machines that they are into NFS repositories, okay, and we are not really dealing with other kind of, let's say, live migrations, it's better to be sure that you are working with the same versions of Oracle VM whenever you are moving these VMs from one repository to another, okay? So, live migration approaches. So, Well, you have to migrate VMs to a different server within the same pool, okay? So this is the most common operation, so this is what we are calling memory migration. Or you can migrate a running VM and migrate its local storage to a different server within the same server pool that it has to present also some additional storage for this VM. So this is a kind of particular migration. So a memory-only migration, okay, it's the most traditional migration where you have, let's say, a VM which is running to a core, okay, on OVS server, and for any reason you want to push it to another server. Okay, so we have to select a server from the list as we are saying here, and in this case you have to be sure that enough memory is presented into this server in order to run your VM without any issues. Otherwise, storage live migration, it migrates a live machine, virtual machine to a different server into the server pool and move also the local and configuration files, okay? So again, you have to be sure, as you can see here, that this server is presenting the adequate characteristics for this kind of migration. So now how you have to enable the high availability. So you have to work with a clustered server pool, which is already giving high availability, and then you have to go and check that the high availability setup is chosen, okay, for this virtual machine, and everything should work without any problems. So we will see here the high availability features and what happens when an Oracle VM server is having a failure. So on the left part of the screen we have an Oracle VM server, okay, which is having, let's say, a kind of failure. So in this case, the server pool is enabled with a high availability, so it's a cluster server pool. The servers, the VMs, VM1 to 3, they have already been tagged with the high availability. So in this case, the Oracle VM server, which is hosting these 3 VMs, is having a kind of hardware problem anyway. And in these cases, the VMs that they are running into this server, they will be restarted, okay? We don't have any kind of live migration. Simply the VM3, if it finds enough resources on the next server, which is called Oracle VM server, okay, it will be restarted from scratch, okay, by just reading the configuration file and the disks associated. So in this case, this kind of restarting, of course, means that you lose, okay, a previous executional context compared to the live migration. The live migration can be seen as a process where you are moving VMs from one place of your system to another without interrupting your operating sequence or whatever, the operations that are running inside. The restart, the high availability means that the server, the virtual machine, has to restart, so you are losing the context. Now, to restart the server to another place, you have to find always enough memory, and if the servers, they are not presenting enough memory because they don't have enough space for these VMs, either VM1, 2, or 3, okay? Or even if you have anti-affinity rules that they are not letting, let's say, the VMs to migrate to servers that they have, okay, they have adequate memory, then the VMs, they will be in a stopped state, okay? And nothing will start to the servers, okay? Now, if the Oracle VM server, which is hosting the 3 VMs, is the last server of or the only server of your pool, and this server fails, then the VM 1, 2, and 3, they will stop, okay? And they will be ready to restart it whenever another Oracle VM server, it will be presented and joined into this server pool. So once again, in order to have, let's say, a high availability, and this is very important for your configurations, okay, you have to provide sufficient number of Oracle VM servers that they will have enough, let's say, CPU and memory, special memory, in order to host, okay, VMs that they will be restarted when the source server, it will fail. So now we have seen a lot of features, and we have let's say one last quiz: which 3 cloning processes are valid? from a virtual machine to a new virtual machine, from a virtual machine to a new template, from a virtual machine to a virtual appliance, from a template to template. So, from a virtual machine to a new virtual machine, yes, you can clone. From a virtual machine to a new template, I don't hear any answers, maybe because I have nobody here. Yes, it's valid. From a virtual machine to a virtual appliance, is it true? I don't think so, because you can clone or create from a virtual appliance a template that it will be used to create a virtual machine. So this choice is wrong. From a template to virtual machine, yes, this choice is true. So actually the correct choices are the A, B, and D, not C, okay? So as a summary, actually, we have seen happily the description of the virtual machine components, all the steps that you have to prepare for the virtual machine creation, different ways to create virtual machines, how you can install your operating systems, okay, the uses of the utilization of templates, virtual appliances, cloning, clone customizers, and how you can access and manage your virtual machines. We have one last lab which will consolidate your, let's say, with a practice, all the things that you have to know, okay, about how you have to create MAC addresses, how you have to create an HTTP server to install your guest operating system, how you have to create a paravirtualized virtual machine, okay, installing a Linux as a guest OS, cloning templates, creating clone customizer, migrating virtual machine, exercising the high availability and the AD Infinity features, and viewing the VNC usage from the Oracle VM manager. Okay, so all these things, we will run them to the labs. The only thing that we might, it might be a little bit different if you run it to your real servers. It is whenever you are running the high availability or even the migration, the live migration. In our systems, it's a little bit slower, okay, than in the real system, simply because, as you have seen into our labs, we are using, let's say, several layers of virtualization, which are adding, of course, an extra overhead in the whole procedure. So this is it. Thank you very much. Practices for lesson 6. So during these practices, we will have to manipulate several aspects of the management of the virtual machines. We are starting from the practice 6-1, reserve MAC addresses for VNX for your future virtual machines. So in this case, you have to go to the tab networking, okay. Then you have to click on the virtual VNX here, okay. And as you can see here, there is not yet anything that it has been allocated. So we have to start to make an allocation, okay, by starting the initial range, and we will, let's say, end up, okay, by giving this kind of settings here, okay, so 0, 0, we have done this kind of preliminary association or allocation. So let's go to the okay, get the nick MAC. Okay, so this is actually what we have created so far, okay. So the first 3 octets, as we have been saying, it is, let's say, the identifier, okay, that has been assigned to Oracle, okay. You should never change the first 3 octets, okay, but you can change the 3 subsequent octets. So this is the end of the practice 6.1. Practice 6.2, in this practice we have to be sure that we can access a web server, okay, which is running on the base domain, and this web server is needed to install a guest operating system in our virtual machines. So let's go to our base server, okay, service HTTPD status, then the HTTP service is up and running. Seed pool, okay, less LA. So we see actually that there are different kind of ISOs here, okay. So we will use these distributions later on, okay. So in this case is what we are supposed to do. We will get actually the Oracle Linux R6U5 server X86, okay, and we have to copy this to the /var www HTML. So let's do it. So as you have seen, the copy operation has been finished, and in this case, let's go to the one of our servers, okay, OVS, no matter the what, OVS VR, let's say 01, why not, okay. And let's try to see if we can get the file from okay, from the HTTP server. And then it's the name that we have to put here, okay. Remote file exists, so excellent. So we can access this file from our server, okay. Then let's go to the var www HTML. So we see actually that we have 2 files. One that was the previous template, okay. So we have to go a little bit further. We have to make a directory. And then we have to mount as a loop device this ISO file, okay. Okay, so the ISO is mounted, so we can see the content of this file, okay, of these files, okay. And this is the end of the 6-2. 6-3. Okay, we have to create, start, and access our first virtual machine, okay, by using, let's say, the Oracle VM Manager user interface. Of course, we can do it by using, let's say, command line, okay, which is much faster sometimes, okay. So let's go first to our pool, okay. Try to find my mouse here, okay. Server pool, right click, okay. Create virtual machine. So we can create this to the pool, or you can create also this virtual machine on a server. Okay, create virtual machine again. And then we have a guided path, okay. So we will create a new virtual machine. Next. And then we have to provide which repository, okay, which will be the name PVM1, okay. If this virtual machine will have, let's say, high availability, we have to choose it, okay. Anyway, in our system, we have to work with Linux 6 USB tablet here, okay. Came up English, it is a PVM, okay. Memory, okay. So these are the settings that we are supposed to enter, okay. Then the next step it is to go to network settings. So we have to choose here the advenic, okay. So it will have a dynamic address, okay, that it will be associated with the VMnet. Next. So we have to create and arrange maybe the disks, okay. So virtual disk, okay, find the virtual disks. So we have to go to PVM disk 1, okay, that they are already there, okay. Second virtual disk, PVM 1 disk 2, okay. Next. So remember that in our case, okay, we have to boot a PVM, okay. So we have to choose the PXE option, and then you have to enter here the network path from where we have to get actually the content, okay, of our servers for ISO // So this is the directory that we have already created, okay. Okay, so it's working. Have to go back to our wizard here. Okay, network path is okay, ISO, okay, next. Okay, no tags. So in the previous steps we have set up actually several steps to configure our PVM, and now the PVM is created, okay, but as you see here, the state of the PVM is stopped. So if you click here to this arrow, okay, then you will get actually the configuration that we have created so far, okay. This PVM, whenever it will be manipulated by the system, it has this internal UUID, okay. The networks, VMnet, okay, with this allocated MAC address, okay, and the two disks, okay, disk 1 and the disk 2. So the disk 1 is the first and the disk 2 is the second disk, okay. So once that this virtual machine is ready, then we choose it and we will start it by clicking this green arrow. So we will see that the PVM will start, okay. So sometimes this is moving to the second server, so the PVM1 is running, okay, on the OVSVR02, okay, and then in order to access, okay, we have to launch a console, a VNC console. You click here. So what you see here, it's the booting phase of this VM. So normally, if everything is well configured, then from the network path, we will get the installation CD, excellent, okay? And then this is the end of the practice 6.3. Practice 6.4, install Oracle Linux as the guest operating system in this virtual machine. So in this practice, okay, as you have seen, we will start the installation of an Oracle Linux system into the virtual machine PVM that we have created before, okay. Now, you have to consider that this lab is running to several virtualization components, so we have a lot of layers that they are one of the top of each other's, okay. So this is adding a lot of latency to the systems. The purpose of this lab is just to show you how you can install let's say an operating system into the VM, but we are not expecting that this lab has to be finished by installing a full operating system to the VM. So we will start this kind of exercise, and you will see that during the installation phase, we will ask you just to perform some additional commands, and then you have simply to cancel. You have to cancel this installation. So you should never, okay, expect that this installation has to go up to the end. Okay. So it is just a little warning. Okay. So now let's go back to our labs. Okay. Just trying to put the cursor in the window. Okay. You accept the choices, okay. English, USK map. Then the installation has to be done from a URL, okay. So in this case is you have to accept the dynamic IP configuration, enable IPv6 protocol, okay. So click once inside and then several tabs. Have to press the tab several times till the OK is highlighted. You push OK. So we are just saying that if for any reason this step is failing, okay, then you have to be sure that the DHCP server is up and running, okay. So now for this we have to enter the IP the HTTP address of our web server. Okay, so you have to be sure that from this address you are getting actually the content, the exploded content of your server, okay, of your ISO. Let's go back again. And here you are just retrieving the packets, okay, and you will see that the installation is starting, okay. So let's wait to get the first screens of the Oracle Linux 6 installation wizards. Okay, let's click next. Okay, once more time, we are not expecting that this installation has to go till the end. Okay. If you want, you can even check the networks. Okay, you can click edit, connect automatically, so the settings are okay. Cancel, close, next. So no matter, you can choose whatever time zone you want. Okay. The most important thing is system clock uses UTC. Okay. So root password, I will put Oracle. No matter if this is a weak password. Lab. Okay. Then use all space. Okay. Next. All the disks. Okay, next. Write changes to the disks. So this is slow because we have several virtualization layers that they are working for this VM. Otherwise, this installation is really fast if you do it to real hosts, not to virtualized hosts with virtualized file systems. Okay, so we will choose the basic installation, base server. We start, okay. So we continue from the break. So as you can see here, the installation process is starting, and as we have been telling you, it might take a lot of time to get accomplished, so we are not really expecting that you finish this step, okay? You let this installer goes on, and then you continue to some additional tasks that you can run, okay, into or from the configuration menu, okay? So now let's go back to this PVM, okay? We click here on the configuration tab, okay? So as you see here, actually the memory which has been allocated is 1024, okay? And then you can try to make some additional modifications into this VM, okay, by just choosing the VM and clicking on the pencil button, okay. So the pencil button is just reading again actually the configuration, and let's try to make some modifications to the vm.cfg to see if this is working or not, okay. Some of them might work, okay, some others not. So if you give a bigger amount of memory, as they're saying here, and you try to make, okay, you have this warning that this cannot be set, okay, the amount of memory cannot be larger than the maximum, okay. So this is the first warning, okay. Then let's put it back to 1024, okay, not to have these warnings, okay. So let's increment the number of processors, okay. Okay, so the number of processors cannot be more than the maximum number of processors, okay. So again, you can either use the arrows, either you put the value, okay. And then let's go to the networks, okay. Add VNIC, okay. So dynamically assigned, okay. And as you can see here, the delete button is still active for this kind of new VNIC, okay. So click OK. As you can see here, creating virtual NIC on the VM, okay. So let's go to edit again the VM, choose it, edit, networks. So actually there are two VNICs that they are working, they have been created, okay. Now we will try something with the disks, so we are going to the disks. Virtual disk. I could be taking this one, why not? Let's take one disk. Or even I can create a new disk here and I will name it PVM1 disk 3, okay, with a size of, let's say, 6 gigabytes. Okay, sparse allocation, why not? So I'm just creating a disk, and this disk will be added. So we have created on the fly this kind of disk, okay. Click OK. Create VM disk mapping of PVM1 running. Okay, so the disk has been created here, as you can see. Okay, so let's continue the editing. Disks. So we will get a physical disk. Although this is not the best practice, but let's try to run this configuration. Okay, and then you click OK. So another job will be triggered. And the physical disk, okay, it is part now of this VM. Okay, you can check the networks. Okay, we have one additional VNIC. Okay, so let's edit again the virtual machine. Boot order. You have to remove this. Okay. So if you do so and you save, so the next time that the virtual machine will be restarted, okay, not this time, okay, the next time it will boot from the first disk, okay. So in this case, what we can do it is that we can cancel the installation. Okay, and you stop the virtual machine. Okay, so let's stop the virtual machine here. So the virtual machine will stop. And again, if you want to see what is happening to the system, okay, so the server is stopped. And this is the end of the practice 6-4. Practice 6-5. Clone the PVM 64-bit template into a new virtual machine. So in this case, we have to create a new virtual machine based on a previous imported template, which is the PVM 64-byte template, host it on the SCSI repository. Okay, so what we need to do it is just to make an initial inspection. Okay, so there are not informations about the networks. There is one disk which is there. Okay, so in this case we are starting by cloning the template. So the clone name should be pvm_vm. VM, okay. VM created from the pvm64 template. Why not? Okay. So we are clicking OK. A task will be launched. So one VM has to be created. Okay, so we will find this VM here. Okay, so what we need to do, let's go to edit this VM. And for the networks, because this information is missing, we are putting the vm.net. Okay, okay. We have done the network association. And then let's see it here, network association. Okay, let's start it. Okay, and then we will try to make a configuration by just giving some additional parameters in order to create correctly the VM. So you will see several prompts and you have to reply with the responses which are written to the activity guide. Chapter 6, page 60. So the local, the host name should be VM1. Okay, I'm having a problem with my keyboard. Let's try to find, okay, VM1. Network. It is the ETH0. Activate network interface on the boot, yes. Address DHCP, okay, the protocol. Okay, so we can see that our server is up and running. He has acquired an IP address. Okay, so as you see, the operation is straightforward, and you can do it very easily. Okay, just want to make an additional test, and I will show you something more if this is working from my base station. Okay. If you have any problems with the configuration of this lab, please call our support, which will be delighted to help you to resolve these issues, so that we have very skillful guys that they are monitoring this session. So if you have any issues, guys, with this configuration, please don't forget that we have a good support made for you, and you can go further. So now, what I want to demonstrate, which is not into these labs, it's that we have already created, let's say, a virtual machine, okay, which is running in one host, which is called OVS VR01. So let's have some fun, okay, just to prove that we know a little bit some things better maybe than others, okay. So I'm into the OVS VR01 XM list. So it's a Xen command that you know already. So you can see that we have already one VM. This is our VM, okay, which is running into this server. So just forget this. Yeah, okay. So this is the ID. Okay. So you will have something more interesting to see. Actually, this is the essence. Okay. So now, if you go out and then IP address of our, let's say, PVM. It's replying from the network, okay? And if you want to get logged into, okay, yes. Here you are. So you have actually get logged into this server, okay? So this is the end of the practice 5.5, okay? With some additional steps that I show you that they are not included into the official activity guide. Okay, so the next thing that I will do, just a small, let's say demo, Control Q, okay. Exit. Let's go again to the SSH, okay. So XM list, XM destroy, one. Yeah, I'm just stopping this VM, okay. And you might see that this is stopped already, okay, with this command. So this is the end of the 6.5. Practice 6-6, we have to create a clone customizer, and we have to use it for any kind of cloning operations. So for this thing, this lab, we have to go to the repositories, choose the SCSI repository, the VM templates, okay. So there is always one template that we have imported, okay, and then we will click on the clone customizer tool here, this one, okay, and then we have to create, let's say, a clone customizer. So let's give just a dummy name, okay, clone custom one, okay, clone customizer, okay. Okay, whatever. Next. Then it has to get created in the SCSI repository, thing cloning. Next. Select the network. Okay, then finish. So we have actually, okay, our new template, okay, and then the next step is to clone the PVM 64 bytes template into two new virtual machines by using the clone customizer that it has been created just right now. Okay, so in this case we go back to our PVM template here. Okay, then clone the template as you know already. Okay, and then in this case we say that we need two clones to create. Okay, so the generic name should be PVM underscore VM. Advanced clone, okay, on the SCSI repository. Okay, whenever you are verifying that everything is okay, then you click OK. So there will be two virtual machines that they have to be created. Okay, we have here the jobs that are running, and if you go to your server and pools, virtual machines. Okay, the first one is coming, and the second one is ready. So we have just now to rename these clones that we have already. Actually, these are our latest clones. So we have already created one previous PVM, one from previous lab. The thing is that we have just to rename this because there are too many PVMs. Okay, PVM underscore VM1. Okay. I'll just click here. Okay. Okay, the renaming is okay. And then we have just to rename the other things here. What we have here, VM, or I will try just to leave it as they are, just to remember that these two are coming from this lab. Okay. So the thing is that we have to just to start one of these servers. Okay. So we start the PVM2, okay, and then we'll try to run it. Okay, as we have done it before, just to show you that it will behave in the same way. Okay, so now you can take the console. Okay. So the only thing that you have to create for these labs, okay, it is just to enter to this virtual machines and give again, let's say, a host name, a network device to boot, okay, activate it. The protocol should be DHCP. The password is written, it's given in the documentation, okay, and then simply you have to get logged into this VM. There is no other, let's say, steps. It's similar to the step that you have seen to the previous lab, okay. So let's do it only for one server, okay, and then if you want you can do it for the other servers as well. Again, you will have to reply to the interview questions, okay. So for this point on, it doesn't really matter if you run the same thing for the PVM1 or the PVM2, okay, this kind of labs. So let's give here, let's say, a name VM2 dot example. I hope that my keyboard is working. Dot, no, come on. Okay. Okay, 0, yes. DHCP, yes, the password. So after the system password, okay, this root password, the system will reboot, okay. And then the only thing that you have to do it is just to get logged into this new server, okay, from this interface, and this will be the end of this activity. So this is the end of the practice 6.6. Okay, so in this practice 6-7, we have to migrate virtual machines. So we have to migrate a running virtual machine from one VM server to another, okay, within the same server pool, running machine, okay. So this is the memory migration, and then we have to migrate a stop virtual machine to a different server within the same server pool. So in the previous lab, we have started this kind of virtual machine, which is called PVM VM2, which is running, as you can see here, to the OVS VR02 example.com, okay, and we will try to migrate this server, okay, this virtual machine, to the OVS VR01. So how we have to perform to this migration? You have simply to click to this machine here, okay, and then you have to choose here this button, of course, no, sorry, this one, migrate or move. Of course, you can do this with the command line. Migrate a running VM to a different server within the same server pool. So this is the right choice. It's what we are expecting to do. So you click next, okay, then specific server, okay, it's the only one, okay. We click finish, and then the migration is starting, okay. The servers are locked, okay, and then you have to wait until to see that this VM, okay, it's already changed the server, okay, from the OVS VR02 is going to the 01, okay, and you have it here, migrate to the VS01, okay. So in these labs it takes some time to perform this kind of migration. Of course, if you have a more advanced system which is not virtualizing all these layers, then the migration is very, very fast. So here it's a little bit slow because we have to execute everything in several virtualization layers. So when the logs they will go away, then the machine will be really running on the final target server. And of course, during this kind of migration, it's the virtual machines configuration. The disks are not migrated, okay? They are still staying into the same repository, which is shared to our pool, okay? So as you have seen here, the logs are released, okay? And since the logs are released, now the migrated VM is running on the OVS. Okay, don't care about this, okay? It is running here, okay? Anyway, you can have from the pool overview where these VMs are running, okay? So now we have to shut down this running machine because it's taking resources from our servers, okay? Yeah. Okay, and then we will perform what we are calling, let's say, a call migration. So the machine is still in the stopping state, okay? And if you want, we will try, let's say, to migrate this machine to the OVS VR02. So this is a call migration. So XM list. Okay. So the migration of the PVM1 has already gone to the server OVS VR2, okay? So what we have done here, it is a kind of call migration, okay? And this last step, it is marking the end of the practice 6.7. In this practice, we will use the high availability feature, okay? So we have to enable the high availability on a running virtual machine. We will try to restart the VM server with the high availability, or where this virtual machine is running with a high availability. Try to restart, of course, why not? And then we will play with this virtual machine by start stopping, and you will see very, very interesting features. So in this case, we have already our friend, the PVM VM2. We have to start it, okay? No matter the server, OVS VR01 or 2, okay? Doesn't matter. What we are expecting is just to see that the VM is starting, okay? It has migrated to the VS VR02 here, okay? Starting. So the state should be running, okay? Let's wait a little bit. Okay, and then let's try to make some modifications to this VM. You get the machine, highlight, edit, implement the high availability. Okay, it's already there. Click OK. If it's not, you have just to click on the checkbox. Okay, and now let's try to restart this server. Okay, this one. Okay, you have to try to restart the server. Okay, are you sure that you want to do this operation? Well, usually this is not the right way to proceed, because before to restart a server which is having anyway running virtual machines, you have to push them to another place, but we are taking the things in another abnormal way. Let's say yes to see what the system will tell us. So normally you should not do this kind of things in the production, okay? It's completely insane. You click here the server, so you have here a failure, okay? So if you look in the details, okay, it will tell you simply that cannot stop or restart the server, which is having or running VMs on it, okay? So please remember, do not try to stop a server which is having VMs. If you recall what I was telling you in the course, it is that if you need for any reason to make this kind of operations, please think first that you have to migrate your virtual machines, okay, into another, let's say, running OVS server, okay? Otherwise, you will face this kind of failures. Of course, there's a hard way to kill the server. If you go into this, well, if you reboot the server, of course, you can do it, okay? There's no problem, okay? Then, because you want to, anyway, perform this task, okay? Then you have maybe to stop the Oracle VM server by killing the virtual machine in which this server is running from your lab machine, okay? So in this case, we will go to the real, okay, station, okay. So as you can see here, we have, let's say, 3 virtual machines, okay, that they are materializing this kind of situation, okay. We have the OVM manager, which is running the manager, the OVS VR, which is, let's say, simulating a physical host to which you run the virtual server, the OVS server 1, and another virtual machine which is simulating another host, which in turn is running, let's say, the OVS server into which you're running your virtual machines. So in order to make a violent, let's say, approach, okay, let's say that you just go there where the server is running and you unplug what? The power or the network, because you are getting crazy, why not, okay? Then in this case, the only possibility that you have from our labs to do this, it is just to launch the command xm destroy, okay, with the name of the server which is running your virtual machine. So this is just a simulation, this is not the real world, okay? In the real world, you have you have physical hosts that they are running your virtual machines. So in the virtual world, you go straight with your feet in front of the blade which is running, let's say, these virtual machines, and then you are switching off the blade. Here we are just killing with xm destroy, and I will use the number of domain 27. Here you are, okay? And then if you do this, let's go. You have just pulled the wire, Okay, we have to verify that we have killed anyway the right server. Okay, yes. So my previous OVS VR2, it is not working anymore. Okay. Another thing that is that it takes some time just to see that the system is getting this information. Okay. And here you are, actually, your server is out of the system, okay? And of course, the pool is having, let's say, a problem here, and this VM is showing you that it is, and it is, it has captured an event in a critical state. Okay. So the Oracle VM server icon, it is a red, that means that it's not running, okay? And then you will see several events that they have to be triggered. Okay, by this situation. So let's see the events now. So the virtual machines are still there, events. Server is offline. The cluster is having a problem. The server has been disconnected, okay? So these are things that they might happen, okay? And then of course, if you click on the health panel, you will get an information that one server is offline, okay? And let's go to see again on the pool, state of virtual machines. So as you notice here, okay, now the machine PVM VM2, it is running on the server OVS VR01. Okay, then I remember that I have been explaining that in this case, what happened to this virtual machine, it is that because the host has stopped to work, okay, and because this VM has been configured with a high availability, then it has restarted, okay, to the server OVS VR01, okay. Now, before to go further, we have just to re-establish manually, okay, the state of the failed server, the server that we have killed, okay. So again, XM list. So what we have done, it was a kind of shutdown, okay, a kill. So if you want to play with these things, maybe you will go now to your physical host and you have to push the button to power it on. In our case, we have to restart the server, okay. XM list here, okay. So you have to wait, however, some time, because as you can see here, the server has started, the domain it's the 28, okay. Don't start immediately the labs. Let's go here and let's make the XM VNC viewer. It's a long lab, is it? Okay, 28. So as you can see here, the server is not still ready, you have to wait until the time that it will show you that I'm an OVS x86 server and I'm ready to run, let's say, the virtualization, okay? Another thing, this is very long because we are running already several virtualization stuff there, okay? So as you see here, the server is starting to boot. And this is the end, okay, of our lab, end of the 6.8. Practice 6-9. Use the anti-affinity feature. So for this lab, we will, let's say, implement that anti-affinity feature, which is used to eliminate, if possible, single point of failures, okay? So for these tasks, we have to create an anti-affinity group. So in order to do this, okay, we have to go back to our usual panel, okay? And from here, okay, we have to go again to the pool. So we have to start anyway one virtual machine that I have been stopping before in order to speed up the startup of my system. Okay. Let's choose one here. Okay, it's not stopped yet. Try to kill it. Okay, it stopped. So let's start one virtual machine. So it went to the server 2, okay. Starting, let's click on the pool again. And let's click on the anti-affinity group. So let's create one anti-affinity group. You give the name that you want. AA. Okay. Test, why not? Next. And then you have to choose actually the machines that they will participate to this anti-affinity group. Okay. The 1 and the 2. Sorry, this one. Finish. So the job, as you can see, it might fail. Okay, if you want to see actually the details, okay, anti-affinity violation, okay, they are running on the same server, okay, physical host, okay. So in this case, okay, then we have to choose another VM, okay. So we still have a failure. here we have the PVM VM1. Okay, so the anti-affinity group we have seen that the previous jobs they have failed, okay, because we could not add a virtual machine which is running on the same server, okay, and I believe, unless I'm wrong, that this machine is not in the same server as the PVM.2. Okay, and this is successful, okay, because this machine is hosted to the OVS VR01 and the other machine is hosted to the OVS VR2, okay. So if you want to see this kind of configuration again, you have to click on the anti-affinity, choose your pool, okay, edit to see the configuration, virtual machines, okay, and then okay, you can make any kind of let's say modifications into these things if you need to change this kind of server. So let's try now. Let's try now a migration. Okay, I will try to migrate this server. Okay, to move this to another server into the same pool. Okay. As you see here, this is a failure. Why there's a failure? Simply because, let's say, in this case, one server of the anti-affinity group is already hosted to the OVS2, okay? And the PVM has to be hosted to another server than the OVS VR2, okay? So we have a failure. And in this case, in order to be able to migrate them successfully, you have to have, let's say, some additional servers where this kind of combination might run, okay? So this is the end of the practice 6.9, 6-9. Practice 6-10, view VNIC usage from the Oracle VM Manager. Okay, this is a very small practice. Okay, suppose that you have created a lot of VMs, okay, to which you have allocated VNICs. Okay, so the only way to know exactly what is allocated is either from the command line, either you click into the networking, okay, and then you can see here immediately what are the MAC addresses, okay, the VNICs that they have been associated with your servers and to which networks. So this is it. Okay, so this is the end of the practice 6-10.